The discovery of 3I Atlas was a quiet accident. The Pan-STARRS telescope in Hawaii, a tireless robotic eye scanning the dark for dangerous rocks, flagged a faint streak of light. Usually these streaks are routine. They are asteroids from the belt between Mars and Jupiter, or comets swinging in from the frozen edges of our system. They follow strict predictable paths around the Sun, but the object that would soon be named Atlas was breaking every rule of orbital mechanics before we even knew it was there. Astronomers immediately noticed the speed. It was moving at over 87 kilometers per second relative to the Sun, far too fast to be bound by the Sun's gravity. This was the first red flag. Every rock native to our solar system is a prisoner of the Sun's mass, looping around it forever. Atlas was different. It was unbound. It had dropped into our neighborhood from the emptiness of deep space from the direction of the constellation Lyra, and it was already on its way out. We had seen interstellar visitors before. We remembered Oumuamua, the cigar-shaped scout that puzzled us years prior, and Borisov, the rogue comet. But 3I Atlas was the third, and it was by far the most disturbing. As telescopes around the world swiveled to track it, the data began to paint a picture of something that nature should not be able to create. The first anomaly was its shape. It was tumbling end over end, spinning every 7 hours. By measuring how its brightness changed as it spun, flashing bright, then going nearly invisible, then bright again, astronomers realized it was extremely elongated. It was either a long, thin cylinder or a flat pancake-like disk. It was at least 10 times longer than it was wide. In the chaotic violence of space, rocks smash into each other and break into rough potato-like shapes. Nature does not tend to sculpt perfect long shards or flat polished disks. Then came the surface composition. It was dark red, suggesting it had been baked by cosmic radiation for millions of years, but it was also strangely reflective in certain angles, almost metallic. However, these physical oddities were just curiosities compared to what happened when Atlas reached its closest point to the Sun. This was the moment the scientific community held its breath. When a comet gets close to the Sun, the heat boils the ice frozen on its surface. This creates a tail of gas and dust, a beautiful glowing streamer. This outgassing acts like a rocket engine. The gas shoots one way and the comet is pushed the other way. This is a known phenomenon called non-gravitational acceleration. We watched Atlas pass the Sun, we waited for the tail, we waited for the heat to crack it open and reveal its icy heart. But there was nothing. Atlas remained a dead, dry point of light. There was no coma, no tail, no cloud of gas. It appeared to be a solid piece of rock or metal completely frozen. And yet as it began its journey back out into the dark, something impossible happened. It sped up. According to the laws of physics, as an object moves away from a star, the star's gravity should pull it back, slowing it down. Atlas did slow down, but less than it should have. It was being pushed. Something was giving it an extra kick, pushing it away from the Sun. The debate exploded instantly. If it were a comet, the invisible gas jets would explain the push, but our most sensitive infrared space telescopes looked for heat, for gas, for water, for carbon dioxide. They found zero evidence of outgassing. It was a dry object behaving like a rocket. The scientific community fractured into two desperate camps. The naturalists tried to save the standard model. They proposed exotic theories. Perhaps it was a hydrogen iceberg, a chunk of frozen hydrogen formed in a giant molecular cloud. If hydrogen sublimated turned to gas, it would be invisible from Earth, explaining the lack of a tail while providing the push. Others suggested it was a dust bunny, a collection of dust so loose and fluffy that sunlight pressure could push it. But these theories crumbled under scrutiny. A hydrogen iceberg would have evaporated long before reaching the inner solar system. A dust bunny of that size would have been torn apart by the Sun's gravity and rotation. Then there was the second camp, the one that spoke in hushed tones at first, then with growing confidence. The artificial origin proponents. They looked at the data, the extreme shape, the lack of heat emission, the strange tumbling motion, and crucially, the inexplicable acceleration. They plugged these variables into their models and found only one solution that fit perfectly, without needing exotic, never-before-seen types of ice. The solution was solar radiation pressure. Light carries momentum. When sunlight hits a surface and bounces off it imparts a tiny push. For a heavy rock, this push is meaningless. But if an object is incredibly light, incredibly thin, and has a large surface area, sunlight becomes a powerful wind. If Atlas was a flat, ultra-thin sheet of material less than a millimeter thick, but spanning the size of a football field, the push from the sun's light would explain its acceleration perfectly. It matched the data exactly. But nature does not make giant, ultra-thin reflective sails. If Atlas was being pushed by light, it meant Atlas was engineered. Getty images. The implications were terrifying and electrifying. Was it a piece of a broken Dyson sphere from a dead civilization? Was it a discarded layer of a launch vehicle? Or more frighteningly, was it a probe? A sensor sent to scan our habitable zone. The trajectory analysis showed that Atlas had passed curiously close to Earth's orbital plane. It had taken a tour of the Goldilocks zone before accelerating out. It was not just a random stone falling through the void. It looked like a visitor checking the windows of a house. As the object raced past the orbit of Jupiter, fading from the view of our optical telescopes, we tried to listen. The world's largest radio telescopes turned their giant dishes toward the receding dot. They listened for a beeper, hum, a sequence of prime numbers, any sign that the object was phoning home. We heard only static, the silence of the void. But the silence did not mean it was just a rock. A derelict ship does not speak. A piece of space junk drifting between stars does not broadcast. The Atlas event changed everything because it removed the safety of assumption. Before Atlas, we assumed that everything moving through the sky was a rock until proven otherwise. After Atlas, we had to face the reality that we could not explain the movement of the object using the laws of geology. We needed the laws of engineering. It forced humanity to look at the stars not as a wallpaper of pretty lights, but as a deep, dark ocean. We had always assumed we were the only fish in the sea, or at least that the other fish were so far away they didn't matter. But the anomaly of 3i Atlas suggested that there was traffic in the water. It left us with a haunting realization. The data was robust, the acceleration was real, the lack of a tail was real. We had tracked an object that behaved like a machine, moved like a machine, and looked like a machine. It came to our front door, accelerated, and left. We are left standing on the porch, staring into the dark, clutching our hard drives full of impossible numbers, forced to ask the one question that changes our place in the universe forever. Are we alone? As the engines of the 3i Atlas spacecraft dim, the bright blue fire that propelled it away from Earth fades into a tiny dying ember. We watch it go moving further and further away until it is swallowed by the heavy curtain of the dark. The ship is no longer a machine defined by huge metal plates and complex wires. It is now just a speck of dust floating in a cathedral of shadows. We leave the warmth of the inner planets behind. We leave the familiar neighborhood of Mars and Jupiter. We are moving into the true unknown. This is the transition into the deep dark. Here, the influence of our sun begins to die. For a long time, the sun was a giant ball of fire dominating the sky, giving heat and light and direction. It was the king of our sky. But out here, billions of kilometers away from Earth, the sun is just another star. It is brighter than the others, yes, but it looks small and helpless. It provides no heat. If you were to step outside the ship, the sunlight would offer no comfort. The cold here would not just freeze you, it would shatter you. We are entering the freezer of the universe. First, we must pass through the outer walls of our home. Scientists call this the Oort cloud. Imagine a giant spherical shell surrounding our entire solar system, like the skin of a fruit or a massive bubble. But this skin is made of ice rock and ancient cosmic debris. These are the leftovers from when the solar system was born. They are the silent ghosts of planets that never formed. These chunks of ice float in total darkness, some as small as a pebble, others as large as mountains. They drift slowly, lazily circling the sun in orbits that take thousands upon thousands of years to complete one single loop. Passing through the Oort cloud is not like flying through a storm. It is not crowded. The movies show asteroid fields as dangerous places where pilots must dodge rocks every second. That is not real. In reality, the space here is so vast that you could fly for 100 years and never hit a single rock. The pieces of ice are separated by millions of kilometers of nothingness. It is a lonely barrier. It marks the edge of the sun's kingdom. Once we cross this invisible line, we are truly homeless. We are in the wild ocean between the islands of stars. This is the interstellar medium. When we look up at the night sky from Earth, we see black space between the stars and we think it is empty. We think it is a vacuum where nothing exists. That is almost true, but not quite. The space between stars is filled with a very thin soup of gas and dust. It is mostly hydrogen and helium, the simplest elements in the universe. But it is spread out so thinly that it is hard for the human mind to comprehend. On Earth, the air is thick. In a cup of air, there are billions and billions of atoms bouncing off each other. In the interstellar medium, if you held out a cup, you might catch only one single atom. It is a ghost of an atmosphere. Because there is so little matter, there is no friction. If you turn off your engines here, you do not stop, you do not slow down, you simply glide forever, carrying your momentum into eternity. The most overwhelming feature of this place is the silence. Sound requires air to travel. It needs molecules to bump into each other to carry the vibration to your ears. Here the particles are too far apart. A scream, an explosion, a collision, they all happen in absolute silence. If a massive asteroid crashed into the hull of the Atlas spacecraft, ripping the metal apart, it would make no noise at all. It would happen like a silent movie. This silence is heavy. It presses down on you. It is the sound of isolation. And then there is the cold. In this deep expanse, the temperature drops to nearly absolute zero. This is the lowest temperature possible in the laws of physics. Written out, it is nearly minus 270 degrees Celsius. At this temperature, all movement stops. Atoms endure a frozen sleep. It is a cold that does not just chill the skin, it stops time itself on a molecular level. It is a preserved frozen stillness that has lasted for billions of years. We look forward searching for a destination. The nearest neighbour to our Sun is a star called Proxima Centauri. When we say nearest, it is a joke of cosmic proportions. The distance is insanity. To understand this distance, we have to talk about light. Light is the fastest thing in the universe. It can travel around the Earth 7 times in one single second. A beam of light takes only 8 minutes to get from the Sun to the Earth. But to get from our Sun to Proxima Centauri, that same beam of light must travel for over 4 years. Think about that carefully. If you shine a flashlight at our neighbour star, the light will not arrive until 4 years later. And that is light. Our spacecraft, the 3i Atlas, is fast, but it is a snail compared to light. For a human vessel, this journey does not take years, it takes lifetimes. To cross this gap is to commit generations of people to the void. It is an ocean so wide that you cannot see the shore on the other side. The distance is roughly 40 trillion kilometers. It is a number so big it loses meaning. Proxima Centauri is the red dwarf star. It is small, dim and anxious. It sits there in the dark, waiting. Between us and it, there is only the long, flat night. Yet despite the cold, the silence and the terrifying distances, there is a strange and haunting beauty here. The loneliness is not sad, it is majestic. Without the interference of an atmosphere, the stars do not twinkle. They do not shimmer or blink like they do from Earth. They are steady, piercing points of light, like diamonds frozen in black ice. They look like unblinking eyes watching you. The Milky Way stretches across the vision like a river of spilled milk, brighter and more detailed than anything ever seen from the surface of a planet. In this great expanse, you realize how small you are. The drama of Earth, the wars, the noise, the politics, the borders means nothing here. Here there is only existence. The ship moves through the shadow, a tiny spark of human ambition trying to cross the infinite gap. It feels like holding your breath. It is a suspended state of being floating between the world that created you and the world that awaits you. It is a beautiful, cold and endless solitude. This is the space between. This is the great expanse. After the terrifying pull of the black hole, the universe suddenly changes its mood. You drift away from the darkness and into a realm of soft, glowing light. The cold, empty silence of deep space is replaced by something that feels like a warm embrace. You have arrived at the stellar nursery. This is not a place of destruction, it is a place of beginning. Ahead of you lies one of the most famous structures in the galaxy, often called the Orion Nebula. It does not look like a solid object. Instead, it looks like a majestic painting splashed across the sky by a giant artist. It is a colossal cloud of gas and dust stretching out for light years. The colours here are breathtaking. You see deep velvet purples blending into soft pinks. There are rivers of emerald green and ribbons of bright blue. These colours come from the different gases floating in the cloud, glowing under the light of nearby stars. It feels less like outer space and more like a dream. As you move deeper, you see shapes rising from the mist. They look like towering mountains or 3 giant fingers pointing up into the cosmos. These are the pillars of creation. They are so massive that our entire solar system could fit inside a tiny piece of one pillar. But they are not made of stone. They are made of cold hydrogen gas and dark cosmic dust. Despite their size, they look fragile, like smoke hanging in the air on a still day. There is a sense of peace here. The violent spinning of the rest of the universe seems to slow down. It is quiet. It is waiting. You float closer to one of these dark, cloudy pillars. To your eyes, it looks thick and foggy like a storm cloud on Earth, but this cloud is the womb of stars. The Gathering. Let us look at what is happening inside this beautiful cloud. The space here is filled with atoms, mostly hydrogen and helium. For a long time, these tiny particles just float around lonely and cold. They are the leftovers from old stars that died billions of years ago. They are waiting to be reused. Then something happens. Maybe a shockwave from a distant explosion passes through, or perhaps a nearby star moves past. It gives the cloud a gentle push. Suddenly, gravity wakes up. Gravity is the invisible hands of the universe. It begins to pull the dust and gas particles toward each other. Imagine a million tiny magnets all clicking together. A small clump of dust forms. Because it is now heavier, it has more gravity, so it pulls in even more dust. It starts to grow. The clump becomes a ball. As more gas rushes inward, the ball begins to spin. It is like a figure skater pulling her arms in to spin faster. The giant cloud is no longer just floating, it is dancing. It swirls around a central point, moving faster and faster. The warming. As the ball of gas squeezes tighter, something magical happens. It starts to get warm. In the vast cold of space, heat is a rare gift. But here inside the thick blanket of dust, the temperature is rising. The atoms are crashing into each other with great speed. The friction creates heat. The center of this spinning ball is now a protostar. It is a baby star not yet fully awake. It glows with a dull red light like a coal in a dying fire. It is trying to ignite, trying to become a sun, but it is not quite ready. The pressure is immense. The gravity is hugging the baby star tighter and tighter, squeezing it with the weight of 1,000 planets. The heat rises from hundreds of degrees to thousands and then to millions. It is a battle between two forces. Gravity is pushing in, trying to crush the star. The heat is pushing out, trying to expand it. This struggle continues for thousands of years. It is a chaotic, violent process. Yet from the outside, the nebula looks calm and serene, glowing softly like a lantern. The ignition. Finally, the moment of birth arrives. Deep in the core of the protostar, the temperature reaches a critical point about 10 million degrees. It is now hot enough for a process called nuclear fusion to begin. This is the secret engine of the universe. The hydrogen atoms move so fast that they smash into each other and fuse, creating helium. When they do this, they release a tiny burst of pure energy. Now imagine trillions of atoms doing this at the exact same second. Boom! A shockwave of light blasts outward. The baby star has officially turned on. It is no longer just a hot ball of gas. It is a living star. The sudden burst of energy creates a powerful wind known as a stellar wind. This wind acts like a broom. It blows away the leftover dust and gas that was hiding the star. The thick dark curtains of the nebula are pushed aside. For the first time, the brilliant light of the new star shines free. It is a blinding diamond white blue. It is fierce and energetic. It illuminates the surrounding clouds, making them glow in bright oranges and golds. The dark pillar where it was born now looks like it is on fire, lit up by the newborn sun. The feeling of rebirth. Watching this process, you feel a profound sense of connection. You realize that this is a cycle. The dust that made this star came from old stars that died long ago. Nothing in the universe is ever truly wasted. Everything is recycled. It feels warm, not just physically, but emotionally. It is a reminder that even in the darkest, coldest places, light can be created. Around the new star, some of the leftover dust does not get blown away. It continues to spin in a flat disk. Over millions of years, these little leftovers might clump together to form planets. Maybe one day on one of those planets, eyes will open and look back up at this nebula, wondering where they came from. But for now, there is just the star. It is young, wild, and stable. It has found its balance. It pushes back against gravity and shines its light into the void, saying, "I am here." As you drift away from the nursery, leaving the pillars of creation behind you, carry the warmth of that birth with you. The universe is not just a machine, it is a garden. And in this garden, flowers of light are blooming all the time, banishing the dark one star at a time. As we pull our view backward, retreating from the warmth of our local star, the sun begins to shrink. It fades from a blinding orb of fire into a bright star, then into a simple dot of light, and finally it merges into a vast glowing background. We are no longer observing a solar system, we are witnessing a structure of impossible scale. We have arrived at the Island of Light. This is our home address in the universe, the Milky Way. Seen from this great distance, the galaxy does not look like the streak of milk we see in our night sky on Earth. Instead, it reveals itself as a magnificent flat disk. It is a masterpiece of cosmic architecture glowing against the absolute blackness of the void. It looks like a great pinwheel made of diamond dust and soft gas. Suspended in the endless dark ocean of space, the feeling here is not one of chaos, but of a deep, heavy silence. It is majestic, it is ancient. The first thing you notice is the light. It is not the light of one sun, but the combined glow of hundreds of billions of stars. Imagine every grain of sand on every beach on Earth and turn each grain into a burning star. That is the scale we are looking at. Yet from here, individual stars are lost. They blend together to form a soft, creamy luminescence that defines the shape of the galaxy. The structure is defined by its arms. This is a spiral galaxy. It does not look like a solid plate, but rather like a whirlpool in a river of light. Long, wrathful curves wrap around the center. These are the spiral arms. They are not rigid structures. They are waves of density, places where gravity has squeezed gas clouds until they ignite into new stars. These arms are blue and white, shining with the intense energy of young hot stars that have just been born. Between these bright arms we see dark lanes. These look like cracks or shadows in the island. In reality, they are vast rivers of cosmic dust, thick clouds of material waiting to become future solar systems. The contrast between the brilliant white arms and the deep black dust lanes makes the galaxy look like a painting created by a giant hand. At the very heart of this island lies the galactic core. Here the stars are packed much closer together. The light shifts from the blue of the arms to an intense warm yellow and orange. This tells us that the stars here are older. They have been burning for a very long time. The center is a bulging ball of light glowing fiercely. While we cannot see it with our eyes, we know that deep inside this bright ball lies a heavy anchor, a point of gravity so strong that it holds the entire island together. Everything in this island is moving. However, the motion is deceptive. If you were to watch the Milky Way for a human lifetime, it would appear perfectly frozen like a photograph, but it is spinning. The entire disk rotates around the center, but it moves with a slowness that is hard to comprehend. This is a cosmic ballet that takes ages to complete. Our sun and all the stars around us are travelling at tremendous speeds, yet the distance they must travel is so vast that the rotation seems to take forever. It takes the sun approximately 225 million to 250 million Earth years to complete just one single lap around the galaxy. Think about that time frame. The last time our solar system was in this exact position in its orbit, human beings did not exist. The dinosaurs were just beginning to rise. The continents on Earth were shaped completely differently. The galaxy turned with a majestic, heavy momentum. It is a clock where one tick takes millions of years. It reminds us that the universe operates on a timescale that makes human history feel like less than a single second. Now let us look for our place in this grand city of stars. Where is the Earth? If the Milky Way is a bustling metropolis, we do not live downtown. We are not in the bright, crowded and chaotic center. We are also not out in the dark, lonely edges where the stars are sparse. We are located in the suburbs. We reside in a quiet, comfortable neighborhood known as the Orion Arm. It is not even one of the major giant arms of the spiral. It is a smaller spur, a bridge of stars located between two larger arms. From this vantage point, we can see how truly humble our position is. We are about 26,000 light years from the center. We are far enough away from the dangerous radiation and overcrowding of the core to allow life to flourish in peace. From this outside perspective, our sun is just one average yellow speck among billions. There is no giant arrow pointing to it. There is nothing to mark it as special. It is simply one tiny member of a procession of billions marching slowly through the dark. Yet this location creates a feeling of safety. Nestled in the Orion Arm, we are protected. We drift through the vacuum carried along by the gravity of the galaxy. We are part of a collective flow. To see the Earth from here is to understand that we are passengers on a much larger vessel. The Earth orbits the Sun, but the Sun orbits the heart of the Milky Way. We are travelling on a ship made of light, sailing through the universe. The sheer size of the island of light is humbling. From one edge of the disk to the other, it measures about 100,000 light years. This means that a beam of light, the fastest thing in the universe, would take 100,000 years to cross from one side to the other. As we drift here watching this silent, spinning giant, a sense of belonging washes over us. The calcium in our bones, the iron in our blood, and the carbon in our DNA were all cooked inside the hearts of stars that died in this very galaxy long ago. We are not just looking at a collection of stars, we are looking at our ancestors. We are looking at the garden where the seeds of life were sown. The Milky Way hangs in the void, a lonely, beautiful raft of energy. It is an island of order in a universe of entropy. It continues its slow, graceful spin, carrying us and billions of other potential worlds on a journey that has no end. It is a view of terrible beauty and peaceful majesty, A reminder that we are small, but we are part of something wonderfully magnificent. We have left the quiet, spacious suburbs of the galaxy behind. Our journey now takes us inward, leaving the spiral arms where our own sun resides, and diving deep into the downtown of the Milky Way. As we travel thousands of light years closer to the core, the first thing you notice is the sky. It is no longer a canvas of black sprinkled with lonely diamonds. Here the darkness is drowning in light. We are entering the galactic bulge. In our neighbourhood of space stars are separated by vast, empty oceans of nothingness. But here the stars are packed together like people in a crowded market. If you lived on a planet orbiting a star in this region, you would never know true night. The sky would remain a blazing tapestry of a million suns, shining with an intensity that would cast shadows even at midnight. These are not the young blue energetic stars we saw in the spiral arms. These are the old ones. They are ancient red giants and orange dwarf stars that were born when the galaxy was just an infant. They have been burning for billions of years, glowing with a cool, ruddy light. They swarm around the centre like bees protecting their hive. But what are they protecting, or rather, what are they trapped by? We push through the clouds of interstellar dust, thick dark fog banks that hide the centre from the view of Earth-bound telescopes. As we pierce through the final veil of dust, we see it. Or to be more accurate, we see the absence of it. We have arrived at the precise centre of our galaxy. We are face to face with the monster. Scientists call it Sagittarius A, pronounced Sagittarius A star. It is a supermassive black hole. It is a name that sounds technical, but the reality is far more terrifying and majestic. Imagine an object with the mass of 4 million suns all crushed down into a space not much larger than our own solar system. This is the anchor of the Milky Way. This is the heavy art that holds our entire galaxy together with its invisible grip. The contrast here is visually overwhelming. Surrounding the black hole is a chaotic, swirling storm of gas and dust. This material is falling toward the hole, spinning faster and faster as it gets closer. As it spins, friction heats it up to millions of degrees. This swirling ring, known as the accretion disk, shines brighter than 1,000 stars. It glows with a fierce, white-hot X-ray intensity. It is the stream of matter before it dies. But in the dead center of this blinding ring of fire, there is a sphere of absolute, perfect blackness. It is a black so deep it looks like a hole punched through the fabric of reality. This is the silhouette of the void. It is the shadow of the beast. We are witnessing the ultimate battle between light and dark. The ancient stars and the hot gas provide the light, but the black hole consumes it. The gravity here is so strong that it bends the path of light itself. You can see the background stars warping and stretching, smearing out into curved lines around the black hole. It acts like a giant cosmic glass lens, distorting everything behind it. It is dizzying to watch, like looking at the world through the bottom of a wine glass. Let us move closer, but not too close. We must stay safely outside the point of no return. This invisible boundary is called the event horizon. It is the edge of the cliff. If you were to drift across this line, there is no engine in the universe powerful enough to push you back out. Not even light, the fastest thing in existence, travelling at 1 billion kilometers per hour, can escape. Once light crosses that line, it is gone forever. Inside, all paths lead downward to the singularity, a point where space and time as we know them cease to exist. But the most mysterious thing about this place is not just the crushing gravity, it is what happens to time. Einstein taught us that gravity does not just pull on objects, it pulls on time itself. The stronger the gravity, the slower time moves. Back on Earth, gravity is weak, so time flows like a rushing river. But here at the edge of the supermassive black hole, the river of time turns into a sluggish swamp. If we were to send a probe down close to the event horizon while we stayed back here to watch, we would see something impossible. As the probe gets closer to the darkness, it would start to move in slow motion. We would see its clock ticking slower and slower. To the probe, everything is normal, it is falling fast. But to us watching from a distance, the probe seems to freeze. At the very edge, right before it vanishes into the black, the probe would appear to stop completely. It would hang there frozen in time in a ghostly image, fading slowly to red and then to black. To our eyes, it never truly falls in, it just fades away into eternity. This is the power of the heart of darkness. It is a place where the future and the past are twisted. If you could survive standing near the event horizon for just a few hours, and then return to Earth, you might find that years or even centuries have passed for the people you left behind. You would be a time traveller jumping into the future not by magic, but by the sheer weight of the black hole. The feeling here is not one of violence despite the heat and the radiation. It is a feeling of profound silence. It is the silence of a king sitting on his throne. The red giant stars whip around the black hole at incredible speeds, dancing to the tune of its gravity. Yet the hole itself sits motionless, silent and dark. It waits. It does not hunt. It simply accepts whatever wanders too close. It is a reminder of the ultimate destiny of the universe. Gravity always wins. It is the patient sculptor of the cosmos. It built the stars, it built the galaxies, and here in the deepest shadow it reigns supreme. As we prepare to pull away, fighting against the pull that wants to drag us down into the abyss, we take one last look at the eye of the galaxy. It is terrifying, yes, but it is also beautiful. It is the engine that drives our galaxy, a chaotic generator of energy and a graveyard of light. It is the end of time, and yet it is the center of everything. We fire our engines. We turn our backs on the abyss. We head upward, out of the gravitational well, moving away from the heavy, slow time of the center, and back toward the light, fast-moving spiral arms where humanity sleeps, unaware of the giant sleeping dragon in the heart of their home. As we pull away from the comfortable spiral arms of our home, the Milky Way, we drift into the deep, silent ocean of intergalactic space. Looking back, our galaxy looks like a shining island of light, a spinning pinwheel of diamonds floating in the dark. But if we turn our gaze outward, we realize something profound. We are not alone in this dark room. We have neighbors. This region of space is known as the local group. It is a cosmic neighborhood where gravity acts as an invisible string tying a family of more than 50 galaxies together in a loose drifting embrace. The little companions, the Magellanic Clouds. Before we reach the true giant next door, we first notice two smaller glowing patches of light hovering near the Milky Way. These are the Magellanic Clouds. Think of them not as strangers, but as younger siblings playfully running circles around a big brother. The Large Magellanic Cloud and the Small Magellanic Cloud are what astronomers call dwarf galaxies. Unlike the perfect organized spiral shape of our home, these two are wild, irregular, and chaotic. They look like splashes of milk spilled across the black canvas of space. These clouds are incredibly close to us, roughly 160,000 light-years away. In cosmic terms, that is right on our doorstep. They are so close that the Milky Way's heavy gravity is actually interacting with them right now. Our gravity is stripping streams of gas away from them, creating a long bridge of material called the Magellanic Stream. It is a physical connection, a holding of hands between galaxies. Because they are being squeezed and pulled by our gravity, these little galaxies are full of energy. They are factories of life birthing new stars at a furious rate. One specific area in the Large Magellanic Cloud, called the Tarantula Nebula, is one of the most active star nurseries in our entire corner of the universe. If that nebula were as close to us as the Orion Nebula, it would cast shadows on Earth at night. They are the vibrant, energetic dancers in our local court, keeping the edges of our galaxy alive with motion. The queen of the night, Andromeda. But if we look past the clouds, peering about 2.5 million light-years into the distance, we see her, the Andromeda Galaxy. She is the Milky Way's twin, but she is bigger, brighter, and holds perhaps 1 trillion stars, more than double what our galaxy holds. From a distance, Andromeda glows with a soft, mysterious light. She is a majestic spiral tilted slightly toward us, showing off her glowing rings of dust and fire. For a long time, humans thought the universe was static, that things just stayed where they were. Later we learned that most galaxies are rushing away from us because the universe is expanding. But Andromeda is different. She is the exception. She is rushing toward us. Right now, as you read this, the Milky Way and Andromeda are falling toward each other at a speed of about 110 kilometers per second. It is not an attack. It is a gravitational attraction. It is a cosmic romance that has been millions of years in the making. Gravity, the same force that keeps your feet on the ground and the moon in the sky, is pulling these two giants together across the void. They are destined to meet. The great dance, a future union. The word collision sounds violent. It sounds like a car crash full of destruction and broken glass. But when galaxies meet, it is not a crash, it is a dance. It is a merger. To understand this, you must remember how empty space actually is. Galaxies are not solid objects. They are mostly empty space sprinkled with stars. Imagine two swarms of bees flying toward each other. If they fly through each other, the bees representing the stars rarely hit one another because the raw space between them is so vast. The distance between stars is enormous. Even if Andromeda slams into us, the chances of our sun physically crashing into another star are almost zero. We will simply slip past each other like ghosts in the night. The solar system will likely survive the entire event, perhaps just being flung to a new location in the newly formed galaxy. This event, which scientists have playfully named Milkomeda, will begin in earnest in about 4 billion years, the sky of the future. If humans or our descendants are still on Earth to watch it, the night sky will become the most beautiful painting ever created. It will be a slow-motion spectacle lasting billions of years. At first, Andromeda will grow larger and larger in the sky. Instead of a small smudge of light, she will look like a second Milky Way, a looming vertical band of light that rivals our own. Then, as gravity takes hold, the perfect spiral shapes of both galaxies will begin to distort. The neat arms will be stretched out into long tails of stars like ribbons swirling in the wind. This is called the tidal dance. Gravity will pull long streamers of stars out into the darkness, creating a shape that looks like an embrace. As the cores of the galaxies approach each other, the gas clouds within them will smash together. Unlike the stars, the huge clouds of hydrogen gas do collide. This will trigger a fireworks show of unprecedented scale. Shockwaves will ripple through the gas, igniting a starburst. Millions of new stars will turn on at once, lighting up the night in brilliant blue and pink. The sky will be so bright with newborn stars that it might be possible to read a book at midnight by their light alone. Harmony, not destruction. This process is slow. It is a waltz that takes billions of years to complete. The two galaxies will pass through each other, stretch out, stop, and then fall back together again. They will swing back and forth, mixing their stars until they finally settle down. The chaos of the spirals will eventually fade. The dark lanes of dust will be consumed by the birth of new stars. What remains will be a single massive elliptical galaxy, a giant ball of old golden stars. The supermassive black holes at the centers of both galaxies will eventually find each other, spiraling inward until they merge into one titanic heart. The Milky Way will not die. Andromeda will not die. They will simply change. They will evolve. There is something deeply romantic about this destiny. It tells us that on the grandest scale, the universe leans toward connection. We are not isolated islands destined to drift alone in the dark forever. We are moving toward a union. The future of our galaxy is not to be alone, but to become part of something greater, a massive city of stars where the night sky is twice as bright and the history of two worlds becomes one. It is the ultimate marriage of the heavens, a peaceful glowing embrace that will last for the rest of time. As we pull back from the spiral arms of our home galaxy, the view changes dramatically. We are no longer looking at individual stars or nebulae. We are looking at entire islands of light. We have entered the realm of the local group. Imagine a small village scattered across a vast dark ocean. That is the local group. It is a collection of over 50 galaxies bound together by the invisible ropes of gravity. Dominating this village are two giants, our own Milky Way and the massive Andromeda galaxy. They are the queens of this territory, surrounded by a retinue of smaller dwarf galaxies that buzz around them like fireflies. From this vantage point, Andromeda is no longer just a smudge in the night sky. It is a magnificent, swirling disk larger than our own home. It glows with the light of 1 trillion stars. If you look closely, you can sense the slow, rhythmic dance occurring here. Gravity is pulling the Milky Way and Andromeda toward each other. In about 4 billion years, they will collide and merge, but right now it looks like a silent, majestic waltz frozen in time. Between these galaxies, the space is not empty, but it is thin. There are streams of gas remnants of old collisions and lone stars that have been kicked out of their homes, wandering the dark forever. Yet this is still a neighborhood. We are still close to home. The distances here are measured in millions of light years. To a human mind that is incomprehensible, but on the cosmic scale it is merely a walk across the street. However, as we accelerate outward, leaving the local group behind, the scenery shifts. The comfort of our galactic village fades into a tiny speck of light and then it is gone. We are now entering the deep ocean. We are entering the voids. The structure of the universe is often compared to a spiderweb or a sponge. The galaxies cling to thin filaments, forming long walls and strands of light. But between these strands lie the void's colossal bubbles of almost nothingness. These are the largest structures in the universe, yet they contain the least amount of stuff. We are now floating into one of these great empty spaces. It is like stepping off the edge of a cliff into a bottomless pit. In the local group, you could always see a galaxy nearby. Here in the void, the isolation is absolute. Imagine a sphere of space so large that it would take light traveling at 186,000 miles per second, hundreds of millions of years just to cross it. If you were born on a planet floating alone in the center of one of these voids, you would see a night sky that was almost completely black. You would have no concept of the Milky Way, no concept of Andromeda, and no concept of the cosmic web. You would think the universe was empty, save for your own sun. It wasn't until the 1990s that human telescopes became powerful enough to truly map these regions and realize just how vast they are. This is the Boötes Void, often called the Great Nothing. It is a sphere roughly 300 million light-years across. In a space this size, standard statistics say there should be thousands of galaxies. Instead, we have found only a few dozen. It is a ghost town on a galactic scale. Drifting here, the sensation changes from awe to a profound vibrating silence. In the city, or even in the quietest forest on Earth, there is always sound. There is the wind, the hum of electricity, the beating of your own heart. But here the silence is physical. It is a vacuum that swallows everything. You might expect to feel fear in such a place. The human mind is not built to comprehend this level of isolation. We are social creatures evolved to live in tribes on a crowded planet. To be here, floating in the gap between the walls of the universe, should be terrifying. But strangely, it is not. A feeling of deep, resonant peace begins to wash over you. All the noise of existence has been stripped away. The politics of nations, the worries of daily life, the noise of history, it all vanishes in the face of the void. You realize that most of the universe is not fire and chaos. Most of the universe is this quiet dark and waiting. It is a negative space. Just as a pause in music gives the melody meaning, these voids give the universe its structure. Without the emptiness, the galaxies would have no place to gather. Gravity has swept the house clean, pulling matter into the rich clusters and leaving these vast rooms empty. As you float here, you become aware of the dark energy that permeates this space. While it looks empty, this void is actually pushing outward. It is the engine of the universe's expansion. In these quiet places, the universe is growing, stretching the fabric of space-time, pushing the galaxy walls further apart. It is a silent, invisible power stronger than gravity dominating the fate of the cosmos. The sense of scale here forces an ego death. You're not just a small person in a big room, you're a microscopic spark in an infinite cavern. But instead of making you feel worthless, it makes you feel connected. You are part of the few rare distinct pieces of matter that exist. You are the exception to the rule of emptiness. In the distance, far beyond the reach of normal vision, you can see the faint glow of the walls surrounding this void. They look like distant cities seen from an airplane at night, shimmering sheets of galaxies forming the superclusters. That is where we are headed next, back toward the light, back toward the dense knots of the cosmic web. But for now, we linger in the void. We float in the suspension of the great cosmic ocean. It is a sanctuary of silence. It is a reminder that in the grand scheme of things, the universe is mostly space, mostly freedom, and mostly peace. Here in the nothingness, there is room to breathe. There is no conflict, only the endless velvety dark stretching out for 300 million light-years, holding us in a quiet embrace before we return to the chaos of the light. If you were to step outside of our galaxy, the Milky Way, you would see our neighbours. If you stepped back even further, you would see the clusters of galaxies. But what happens if you zoom out so far that entire galaxies become nothing more than tiny specks of dust? What does the skeleton of the universe actually look like? Welcome to the cosmic web. This is the largest pattern found in mere nature. When we look at the universe at this massive scale, it does not look like a random scattering of stars. Instead, it looks organized. It looks structured. It looks like a vast three-dimensional spiderweb made of light, the structure of shadows and light. Imagine a dark room filled with a thick invisible smoke. Now imagine thin threads of silk stretching across the room connecting different points. Finally, imagine tiny droplets of dew clinging to those silk threads. In this picture, the dew droplets are the galaxies. The silk threads are what we call filaments. These filaments are massive bridges of gas and dark matter that stretch for hundreds of millions of light years. They act as the highways of the universe. Galaxies do not just float randomly. They travel along these filaments, sliding toward the busiest intersections where gravity is strongest. Between these threads, there are giant empty spaces. We call these the voids. These are the loneliest places in existence. They are bubbles of almost pure nothingness spanning hundreds of millions of light years across. The structure of the universe is often compared to a sea sponge or a honeycomb. The matter, the stuff that makes up you, me, and the stars, is only found in the thin walls and intersections of the honeycomb. The rest is just empty dark space. It is a humbling realization the universe is mostly empty and we live on a thin thread of light suspended over a deep abyss of nothing. Laenakia, our immeasurable heaven. For a long time, we knew we lived in the Milky Way, and we knew the Milky Way was part of a group. But recently, scientists realized that our map was too small. We are part of something much, much bigger. We live inside a supercluster called Laniakea. In the Hawaiian language, Laniakea means immeasurable heaven. It is a fitting name. This structure is so large that it is almost impossible for the human mind to truly comprehend. Laniakea is 500 million light-years wide. It contains 100,000 galaxies and the mass of 100 quadrillion suns. But Laniakea is not defined just by its size, it is defined by movement. Just as water flows down a mountain into a valley, galaxies flow through the universe. By mapping the speed and direction of thousands of galaxies, scientists found that we are all flowing together. We are like leaves floating in a massive river, all moving toward the same destination. Every star you can see in the night sky and every galaxy in our neighborhood is part of this same giant family bound together by the invisible gravity of Laniakea, the Great Attractor. If we are moving like a river, where are we going? Deep in the heart of Laniakea there is a gravitational anomaly. It is a place of immense power that is pulling us and thousands of other galaxies toward it. Astronomers call this mysterious region the Great Attractor. It sounds like something from a science fiction movie, but it is very real. It lies about 250 million light-years away from us. The scary part: we cannot see it clearly. It is hidden behind the zone of avoidance, which is the thick band of dust and stars from our own Milky Way galaxy that blocks our view. We can only know it is there by feeling its pull. We can see the galaxies around us rushing toward it at speeds of hundreds of kilometers per second. It is a gravitational monster, like a concentration of mass so dense that it dictates the movement of everything around it. It reminds us that even though we feel distinct and separate on Earth, we are caught in a gravitational current that we cannot control. We are drifting in the cosmic ocean pulled by a shore we cannot see. The universal brain. Perhaps the most shocking thing about the cosmic web is not its size, but its shape. When scientists run computer simulations of the universe's growth creating the cosmic web on a screen and then compare it to a microscopic image of a distinct biological structure, they look almost identical. The cosmic web looks exactly like a neural network. It looks like a brain cell. If you place a picture of a mouse's brain cells next to a picture of the large-scale universe, you might not be able to tell the difference. Both have nodes like galaxies or neurons connected by long filaments like gravity or axons. Both act as networks for transmitting energy and information. This leads to a feeling that is both scientific and spiritual. Is the universe a single giant organism? Are the galaxies just atoms in a much larger body? When we look at the cosmic web, we're not just looking at cold rocks and gas. We are looking at a system that looks alive. The filaments pulse with the flow of matter. The voids breathe with the expansion of dark energy. It is an interconnected tapestry where everything is linked. This is the ultimate view of our reality. We are not isolated. We are not alone. We are a tiny essential spark within a neural network that spans billions of light years. We are part of the universe's nervous system. Standing before this image of the cosmic web, the feeling is absolute awe. It crushes our ego, but it feeds our soul. It tells us that from the smallest atom to the largest supercluster, nature repeats its patterns. We are woven into this web. We are made of the same flow that rushes toward the Great Attractor. We are the children of Laniakea drifting together through the beautiful, terrifying dark. When we look up at the night sky, we are not just looking into space, we are looking back into time. It is a profound realization that transforms a simple glance at the stars into a journey through history. Because light takes time to travel from one place to another, seeing the moon means seeing it as it was over 1 second ago, and seeing the sun means seeing it as it was 8 minutes ago. But if we look past the sun, past the stars in our galaxy, and past the distant galaxies that appear as faint smudges in our telescopes, we eventually hit a wall. We reach a limit to how far back we can see with visible light. This journey backward takes us to a time when the universe was not the vast, dark and empty ocean we know today. Instead, it was a hot, dense and violent place. Imagine a time long before the Earth formed, long before the first star ignited. This is the era of the primordial fireball. In this early stage, the universe was like a thick, glowing fog. It was so hot and crowded that atoms as we know them could not exist. For the first few 100,000 years after the birth of the cosmos, the universe was opaque. It is difficult to imagine a universe without transparency, but think of the inside of a cloud or the interior of a glowing coal in a fire. In this hot soup, particles were crashing into each other with frantic energy. Light existed, but it was trapped. A particle of light known as a photon could not travel very far before it smashed into an electron. It was a chaotic dance where light was a prisoner of the heat, bouncing around endlessly like a ball in a pinball machine. The universe was holding its breath, filled with light that could not escape. Then something miraculous happened. It was a moment of transformation that changed the nature of the cosmos forever. As the universe expanded, it began to cool down. The intense heat that drove the chaotic dance of particles began to fade. Approximately 380,000 years after the beginning, the temperature dropped just enough to about 3,000 degrees, allowing the chaos to settle. This was the moment of recombination. The frantic electrons slowed down enough to be captured by protons, forming the very first atoms of hydrogen and helium. Suddenly the thick fog cleared. The electrons, which had been acting like roadblocks for the light, were now neatly tucked away inside atoms. The pathways were open. The universe shifted from being opaque to being transparent. In that instant, the light that had been trapped for thousands of years was set free. It surged outward in every direction, filling the newfound emptiness of space. This was the first light, a brilliant flash that illuminated the entire cosmos. If you could have been there to see it, it would have been a blindingly bright orange-white glow, as warm as the surface of a star. However, we do not see this light as a bright orange glow today. This leads us to the concept of the echo. That ancient light has been travelling through space for over 13 billion years to reach us. During that incredible journey, the universe has continued to expand, stretching out space itself. As space stretched, it pulled the light waves along with it. What started as visible energetic light waves were stretched out, becoming longer and longer, and losing energy along the way. Over the eons, this light shifted from visible orange to red to infrared, and finally into the realm of microwaves. Today, this ancient light washes over us not as a blinding flash, but as a faint cold whisper. We call this the cosmic microwave background. It is the afterglow of the Big Bang, a fossil of light left over from the moment the universe opened its eyes. It is everywhere. No matter where you point a radio telescope in the sky away from the stars and galaxies, you will find this faint signal. It is uniform and constant, blanketing the entire sky day and night. It is the background hum of the universe, a static hiss that permeates every cubic centimetre of space. In fact, if you remember the old television sets with antennas when you tuned between channels and saw that black and white static, a small percentage of that snow was actually caused by the cosmic microwave background interacting with the antenna. We have literally watched the echo of creation dancing on our TV screens. This radiation feels like nostalgia on a cosmic scale. It is the oldest thing we can ever see or touch. When scientists map this light, they are effectively taking a baby picture of the universe. The map shows us what the cosmos looked like when it was in its infancy. At first glance, this map looks perfectly smooth, suggesting the temperature was exactly the same everywhere. But when we look closer with incredible precision, we see tiny imperfections. These imperfections are faint ripples, minute differences in temperature. One part is slightly warmer, another slightly cooler. These tiny variations are incredibly important. They are the seeds of everything we see today. If the early universe had been perfectly smooth, gravity would have had nothing to pull on. Everything would have remained a thin, even gas. But because there were these tiny clumps, these slightly denser spots, gravity could get to work. Over billions of years, gravity pulled more and more matter into these denser regions. These clumps grew larger and heavier, eventually collapsing to form the first stars and the vast web of galaxies that make up our modern universe. Without those tiny ripples in the ancient light, there would be no galaxies, no sun, no Earth, and no us. Studying the cosmic microwave background gives us a feeling of deep connection to our origins. It reminds us that the universe has a memory. The light that hits our detectors today carries the imprint of the conditions from billions of years ago. It tells us how much matter exists, how fast the universe is expanding, and even hints at the shape of space itself. It is a haunting and beautiful concept. The sound of the beginning is still ringing in our ears, converted into microwaves flowing through our bodies and our planet every second. We are bathed in the relic radiation of our own creation. It serves as a humble reminder that we are part of a vast, unfolding story. The fires that burned at the dawn of time have cooled, but their warmth, however faint, is still here, holding the secrets of how we came to be. This is the ultimate horizon. We cannot see past this wall of light with our eyes, for before this moment the universe was hidden in fog. But by listening to this ancient echo, we understand that we are not separate from the universe. We are the result of its cooling, its expansion, and its long, silent history. The static of the cosmos is the lullaby that has played since the stars were born. Imagine you are watching a movie of a glass vase falling off a table. It hits the floor and shatters into 100 pieces. Now imagine playing that movie backward. The shards fly up from the floor, join perfectly together, and the vase sits unbroken on the table. You immediately know that the second version is fake. It feels wrong. We know instinctively that broken things do not fix themselves and that time only moves in one direction forward. This one-way street is what scientists call the arrow of time. It is the gentle but unstoppable force that carries us from the past through the present and into the future. The engine driving this arrow is a concept called entropy. While the word sounds complex, the idea is actually very simple. Entropy is a measure of disorder or how mixed up things are. The universe loves disorder. It is much easier to have a messy room than a tidy one. It is much natural for a hot cup of coffee to cool down than for a cold cup of coffee to suddenly heat up on its own. Think of the universe as a tightly wound clock. At the very beginning, at the Big Bang, the clock was wound up tight. Everything was organised hot and packed together. But ever since that first moment, the clock has been slowly unwinding. Energy spreads out, heat turns into cold, order turns into chaos. This is not a failure of the universe, it is simply the universe relaxing. It is the natural drift from being tense and energetic to being calm and still. This process is what gives us the sensation of time passing. We are riding the wave of the universe slowly settling down. As we ride this wave, we look out at the night sky. It looks peaceful and unchanging, as if the stars have been there forever and will stay there forever. But the stars too are subject to the arrow of time. Every point of light you see is an old star fighting a battle against gravity. They fight this battle by burning fuel, fusing hydrogen atoms into helium in their cores. But like a candle or a campfire, they only have a limited amount of fuel. They cannot burn forever. The biggest, brightest stars, the beautiful blue and white giants, live the fastest lives. They burn through their fuel with reckless abandon, shining brilliantly for a few million years before exploding and fading away. They are the rock stars of the cosmos, living hard and dying young. But after they are gone, the universe will belong to a different kind of star, the red dwarf. The era of the red dwarfs will be a long, long twilight. These stars are much smaller than our sun, perhaps only a fraction of its size. Because they are small and not very hot, they burn their fuel incredibly slowly. They are miserly with their energy, sipping it gently rather than gulping it down. This allows them to live for trillions of years. Long after our sun has expanded and then shrunk into a cold white cinder, these little red stars will still be glowing. If you were to stand on a planet orbiting a red dwarf in the deep future, the sky would look very different. It would be darker. The brilliant tapestry of the Milky Way would be gone, replaced by a vast empty blackness with only a few dim ruddy points of light. It will be a quieter universe, a sleepy universe. Life might still exist there, huddled close to the faint warmth of these dying embers, watching the galaxy grow old. But even the red dwarfs are not immortal. The arrow of time spares nothing. One by one, over timescales so vast that our human brains cannot truly comprehend them, the red dwarfs will run out of fuel. One by one, the lights will go out. The last star in the universe will eventually flicker and die. When it does, the universe will enter its final era, the dark era. In this distant future, the cosmos will be a graveyard of stellar remnants. There will be black holes, neutron stars and cold rocks drifting in the absolute dark. But even black holes do not last forever. As the physicist Stephen Hawking discovered, black holes slowly leak radiation and they evaporate. Over a period of years, written as a 1 followed by 100 zeros, the black holes will dissolve into nothingness. This leads to the final state of the universe, often called the heat death or the big freeze. Do not let the name scare you. It is not a violent death. It is a state of perfect equilibrium. The clock has fully unwound. The temperature everywhere is exactly the same, just a fraction above absolute zero. No energy flows, no work can be done, nothing changes anymore. The arrow of time finally stops because there is no difference between the past and the future. The universe has fallen into a deep, eternal, dreamless sleep. This story of the future might sound sad. It brings a feeling of melancholy up one-man Mac to think that everything we know, every star and every galaxy will eventually dissolve into cold darkness. But there is a hidden beauty in this ending. If the universe lasted forever, if stars never burned out, if time just circled around and around without consequence, then nothing would be special. A flower is beautiful because we know it will wilt. A summer day is warm and lovely because we know winter is coming. The very fact that the universe is finite, that it has an ending, gives meaning to the now. The arrow of time tells us that we cannot go back. We cannot undo mistakes or relive happy moments. We can only move forward. This makes the present moment the most valuable thing in existence. We are living in the golden age of the universe, the brief shining moment when the stars are bright, when planets are warm, and when life can look up and wonder. We are the universe experiencing itself before it goes to sleep. So do not fear the entropy. Do not fear the winding down of the clock. It is simply the nature of things to rest. The aging of the stars and the eventual fading of the light is a reminder to cherish the warmth we have right now. We are here awake and alive in the glorious era of light. And that is enough. Let us return now in this quiet moment to the very beginning of our journey. Let us go back to that first question posed by the Station 3I Atlas. It is the question that everyone who has ever looked up at the night sky has eventually asked. You look out at the ocean of stars, deep and endless, and you feel a sudden, heavy realization. It is so quiet. This is the great silence. In science, we call this the Fermi paradox. It is a puzzle named after a physicist who simply asked, "Where is everybody?" Think about the numbers for a moment. Our galaxy, the Milky Way, is just one of billions of galaxies. Inside our own galaxy alone, there are hundreds of billions of stars. Many of those stars are like our sun. Mathematics tells us that many of them should have planets, and some of those planets should have liquid water. Even if life is very rare, the sheer number of chances means that the sky should be buzzing with activity. We should hear radio signals. We should see megastructures blocking the light of stars. We should see ships moving between the darkness. But when we point our radio telescopes to the heavens waiting for a hello, we hear only the static hiss of cosmic background radiation. We hear the birth of stars and the death of stars, but we hear no voices. Why is the sky so terribly silent? There are many theories, and some of them are frightening. You might have heard of the dark forest hypothesis. It suggests that the universe is like a dark forest at night. In this forest, every civilization is a hunter with a gun trying to survive. They stay quiet because they are afraid. If they make a noise, if they light a fire, another hunter might see them and attack. In this theory, the silence is not because the universe is empty. The silence is because everyone is hiding. They are holding their breath, terrified of being found. That's a chilling thought. It makes the hair on your arms stand up. It makes you feel like Earth is a small child walking loudly through a dangerous room. But tonight I do not want you to dwell on fear. I want to offer you a different perspective, one that is just as possible and far more beautiful. What if the silence is not a threat? What if the silence is simply a waiting room? Consider the firstborn hypothesis. The universe has existed for roughly 14 billion years. That sounds like a very long time. However, in the grand life of a universe, 14 billion years is actually quite young. The early universe was a violent, hot and chaotic place. It was full of exploding stars and dangerous radiation. It was too unstable for complex life to grow. It has taken this long for the cosmos to cool down, for the heavy elements like carbon and oxygen to form in the hearts of dying stars, and for those elements to come together to make planets like Earth. Maybe we are not late to the party. Maybe we are the very first guests to arrive. Imagine that humanity is the first seed to sprout in a massive empty garden. We look around for other flowers, but we see only soil. We feel lonely, but we are not wrong to be here. We are just early. Someone has to be the first. Someone has to be the first to look up, the first to wonder, the first to build a ship, and the first to dream. Perhaps that burden falls on us. If this is true, then the silence of the sky is not empty space, it is potential space. It is a blank canvas waiting for life to spread. We are not isolated, we are the pioneers. The reason we do not hear anyone else is that they are not born yet. They are waiting for the future millions of years from now when life might be common. We are the elders of the universe. This leads us to the deepest realization of all, a thought that connects the science of the stars to the spirit of your own mind. Think about what you are. Your body is made of atoms. The calcium in your bones, the iron in your blood, the carbon in your DNA, all of these were cooked inside the cores of giant stars that exploded billions of years ago. You are literally made of stardust. You're a piece of the universe that has come together, stood up and opened its eyes. For billions of years, the universe was blind. It was just rocks, gas and fire crashing into each other. It had no way to know itself. It had no way to appreciate its own beauty. A sunset on Mars was just physics. There was no one there to feel the awe of the red light. A nebula was just gas. There was no one to marvel at the colours. But then you happened. Life happened. Consciousness happened. Through your eyes, the universe can finally see itself. Through your mind, the universe can finally wonder about itself. When you feel sad or joyful or curious, that is the universe feeling those things. You are the way the cosmos contemplates its own existence. So why is the sky silent? Perhaps it is silent out of respect. Perhaps it is holding its breath, watching you. It is waiting to see what you will do next. This perspective changes the feeling of loneliness completely. You are not a tiny, insignificant accident floating in a dead void. You are the awakening. You are the morning light breaking over a dark horizon. The silence is not there to make you feel small, it's there to give you room to grow. When you look up at the stars tonight, do not feel afraid of the distance. Do not feel sad that no one is waving back yet. Instead, feel the pride of being the first. Feel the responsibility. If we are the only consciousness in this corner of the galaxy, then we carry the torch of meaning. We bring purpose to the rocks and the gas. We are the searchers, yes, but we are also what is being searched for. We are the voice that the universe has been waiting to hear for 14 billion years. The silence is not an absence of life. The silence is an invitation for you to speak, to live, and to fill the void with your own meaning. You are the proof that the universe is not dead. As long as you are here looking up and wondering, the universe is alive and it is awake. We have reached the end of the road. The great voyage is over. For a long time your mind has been travelling outward, stretching past the boundaries of the sky, past the moon, and into the deep velvet blackness of the cosmos. You have been an explorer of the impossible, drifting on the winds of imagination to places where time bends and light dances. But now the engines of your curiosity are winding down. The fuel of your attention is spent. It is time to turn the ship around. It is time to come home. Let us take one last look over our shoulders before we close the door. Do you remember where we began? It seems like a lifetime ago. We started with a single tiny speck. We followed the journey of that microscopic grain of dust, the traveller we called 3I/Atlas. It was smaller than a grain of sand, floating alone in the vast emptiness. It was a humble beginning, just a piece of rock and ice tumbling through the dark. From that small sea we expanded our view. We watched it dance with gravity. We watched it catch the light of distant suns. Then we moved bigger. We saw the planets spinning in their silent lanes. We saw the great gas giants, those massive balls of storms and clouds standing guard in the outer dark. We saw the red dust of Mars and the burning heat of Venus. We floated past the rings of Saturn, listening to the silence of a billion pieces of ice moving in perfect circles. We saw our own sun, a terrible and beautiful ball of fire giving life to everything we know. But we did not stop there. We went further. We flew out of the solar system, leaving the sun behind until it was just another star in the sky. We drifted through the arms of the Milky Way, seeing rivers of stars flowing like milk across the night. We saw places where stars are born glowing pink and blue in clouds of gas. We saw places where stars die exploding in silent fireworks or collapsing into deep dark wells where no light can escape. We went even further, zooming out until the galaxy itself was just a small spiral, a little pinwheel of light in the dark ocean. We saw the local group of galaxies dancing around each other in a slow cosmic waltz. And finally we saw the superclusters. We saw the great web of the universe where thousands of galaxies are strung together like pearls on invisible strings. We saw the structure of everything, the grand design of the cosmos stretching out for billions of light years. It was beautiful, it was vast, it was overwhelming. But now that image is fading. The great web of lights is getting dim. The superclusters are dissolving into the background. We are floating back, we are shrinking down. The universe is folding itself up like a map being put away after a long trip. We are leaving the edge of space. We are gliding back towards the center. The galaxies blur into soft patches of light. The Milky Way welcomes us back, wrapping its starry arms around us like a warm blanket. We pass the quiet stars. We pass the sleeping planets. We see the blue marble of Earth rising up to meet us. It looks so peaceful from here, wrapped in its thin layer of clouds and air. We drift down through the atmosphere. The black of space turns into the deep indigo of the upper sky and then into the soft darkness of the night. We float down past the sleeping clouds. We drift over the silent oceans and the quiet continents. We find your city, your town, your street. The lights are low, the world is resting. We move through the roof, through the ceiling and into the room where you lie. Here we are. Back in the room, the journey is done. The vast distances of light years have disappeared. All that is left is here and now. Feel the room around you. You do not need to see it. Yes, you know it is there. It is your sanctuary. The shadows in the corners are soft and friendly. The air is still. The only movement is the gentle rise and fall of your own chest. Shift your attention to your body. You are no longer a traveller of the stars. You are a physical being resting in a warm, soft place. Feel the weight of your head sinking into the pillow. It feels heavy, supported, and safe. Let the muscles in your neck release their tension. Imagine a warm, golden liquid flowing down from your neck into your shoulders. Let your shoulders drop away from your ears. Let them sink into the mattress. The journey has made you tired in a good way. Your arms are heavy. They lie by your sides like resting weights. Your hands are open and loose. There is no need to hold on to anything anymore. Not the controls of the ship, not the worries of the day, not the thoughts of tomorrow. Let them all slip through your fingers. Feel the heaviness move down your spine. Your back is fully supported. You're held up by the bed, and beneath that by the floor, and beneath that by the solid earth. Gravity, the same force that holds the galaxies together, is now holding you in a gentle embrace. It is pulling you down, anchoring you, telling you that you do not need to move. You're safe here. Feel your legs becoming heavy. From your hips down your thighs, past your knees and into your ankles. They feel like logs of wood sinking deep into soft mud. Your feet are relaxed. Your toes are still. The energy has left your body, leaving behind a pleasant, warm humming sensation. Now listen to the rhythm of life. Listen to your breath. It is slow and steady. Inhale gently and exhale slowly. With every breath out, you are releasing a little more of the journey. Inhale, thinking of the word calm. Exhale, thinking of the word sleep. Your heart is beating a slow, steady drum. It is the clock of your life ticking quietly in the night. It is slowing down, matching the pace of your relaxing mind. Lub-dub, lub-dub, lub-dub. The universe is still out there. The stars are still burning. The planets are still spinning. The dust is still drifting, but you do not need to watch them anymore. They will be there when you wake up. They can take care of themselves. You have done your part. You have witnessed the wonder. Now your duty is to rest. Imagine a soft black velvet curtain slowly being drawn across your mind. It covers the stars. It covers the galaxies. It covers the thoughts. It covers the room. Say a silent goodbye to the traveller named Atlas. Say a silent goodbye to the swirling nebulas. Say a silent goodbye to the blue earth. Let the darkness wrap around you like a warm cocoon. There is nothing left to see. There is nothing left to understand. There is only the comfort of the pillow, the warmth of the blanket, and the slow rhythmic tide of your breathing. You are drifting on a dark, calm ocean. The water is warm. The waves are gentle. You are floating further and further away from the shore of wakefulness. The horizon is gone. There is only the deep, peaceful now. Let go of the words, let go of the images. Good night to the atoms. Good night to the stars. Good night to the universe. Sleep is coming. It is a heavy, sweet wave washing over you. You are safe. You are home. You are asleep.